Hey, welcome. Hi. Monday here on Kitchen Table Chemistry. And today in Acids and Bases, we're going to talk about conjugate acids, conjugate bases, and some acid-base theory. So, what is an acid and what is a base? I think we all recognize that an acid has a hydrogen ion, but that hydrogen must be able to be dissociated, or an acid must produce hydrogen ions in water. This was an idea first brought up by a gentleman named Arrhenius. Arrhenius is the first person who comes up with this sort of acid-base theory, and he says an acid must produce hydrogen ions in water, and that's what our acid has to be able to do. He also came up with the idea that a base must produce hydroxides in water. And this, however, doesn't always work because not every base produces hydroxides in water. And I'm thinking about examples like ammonia or things like bleach. These are not hydroxides, but they are bases. So we end up with a second acid-base theory, and that second acid-base theory is called the Bronsted-Lowry acid-base theory. In an acid, an acid is a proton donor, and a base is a proton acceptor. And how this works is as such. And I'm going to start off with the example here of HCl, hydrochloric acid. We recognize it's an acid. It starts with a hydrogen. It's a strong acid. Our base we're going to use here is ammonia, NH3. So it is a base. What makes ammonia a base is the ability of it to absorb a hydrogen. So in this reaction, we're going to end up with NH4 plus and Cl minus. Okay, now let's connect them. What happened was this. Our hydrogen went from the acid to the base. That's where the hydrogen was transferred like that. Now, hydrochloric acid was the acid, and the anion that's left behind, the conjugate base is the anion left behind from the acid. And whereas ammonia was our base, now we have ammonium, which is the conjugate acid. The conjugate acid is formed when the base gains a proton. So this is what acid-base theory looks like under Bronsted-Lowry. We have an acid, a base, a conjugate acid. That conjugate acid has always gained a proton. Gained a hydrogen ion or gained a proton. Don't do that. And the anion, which is what's left from the acid. Okay, let me show you perhaps a second example of this. Before I do that, something to think about here. Water can act as both an acid or a base. And that means it is amphoteric. That is a vocab word. To be amphoteric, that means you can act like an acid or like a base. So I'm going to do a quick reaction here with water and water. And we're going to combine them together, and we're going to get hydronium, H3O plus, and hydroxide, OH negative. Now, when I start connecting these things, it doesn't matter which water I choose, but it matters what I label them as after I choose them. So if I want to go from here to here, this water has gained a hydrogen, which means that it had to act as the base. And that means that hydronium over here, this is the conjugate acid. This water, therefore, had to have been the acid. And now that it has lost a hydrogen, this here is now the conjugate base. And that's how we'll label these things up. Water is like that. It can be both an acid or a base. It can gain or it can lose a hydrogen. And when you're like this, you simply want to label the base and the conjugate acid together. Something else like this. If we take hydrogen carbonate with a -1 charge. So here's hydrogen carbonate, HCO3. If we add this to water, H2O, we're now going to get CO3 minus 2 and H3O plus. That's one of the things that we could get. It could actually go the other way as well, but we're going to draw it out this way. And that means that here, having lost a hydrogen, that this hydrogen carbonate had to act as the acid. The remaining particle left behind now is called the conjugate base. Water in this point has acted as the base, and the hydronium formed over here is the conjugate acid. Notice again, as always, my base is connected with my conjugate acid, and my acid is connected with my conjugate base. We're looking at where the hydrogen was transferred from. Here it went from here to here. We lost a hydrogen like that. Here it would have been from here to here. Okay. All right. I'm going to give you a little bit of practice with this and see how you go. We'll be on this today, and we'll probably also be on it a little bit tomorrow. Tomorrow, Tuesday, is the AP Calc test, and I know a lot of you guys are taking it, and I wish you the best of luck with it. Tomorrow will be a very, very small optional assignment. Because of that, I think about 40% of us are going to be on the AP Calc roster for tomorrow. So good luck, good luck, good luck with that AP Calc test. Okay, I hope this goes well for you, and that if there's questions or concerns, as always, let me know. Take care. Bye-bye.